Alright, so now that we've actually finished learning all the algebra that we've got for you in this course, there's nothing actually new to teach you for this unit, so we'll be able to move on to a new unit soon. Before we do that, we're going to have a go at like actually applying the algebra that we've learnt to a few situations because algebra is like an important part of real life in many jobs. Algebra is really, really handy at doing some of the things that I've just listed on the screen. It's really good for taking something that is theoretical or we don't know and actually being able to represent it some way through our variables and our letters and stuff like that. So it lets us like model situations that are unfolding because the algebra that we make can be turned into graphs. So people have been doing a lot of modeling and predicting using algebra and graphs and stuff. Just around like the coronavirus, it actually predicting, the levels of infection and stuff like that, right? Algebra helps us to make those predictions about the future, right? It lets us summarize what's happened, so we can make estimations, we can make predictions, and we can kind of work flexibly and imaginatively because if we can't make predictions about the future, we don't know what's going on. So it lets us actually peer into the future. Because we have these algebraic representations of real life situations. It lets us take things that we don't know and kind of gives us like a model or a way of kind of figuring them out. So algebra is really good at all that stuff. So we're not going to be doing anything too crazy today. We're going to have some basic questions, kind of bringing in some other areas of math. So we might be finding like just doing some counting problems or doing some like area or perimeter problems from shapes. But there's going to be algebra involved to let us be generic. So rather than knowing that the perimeter of my fence is 26 meters, it might be, X meters. So we're going to have a go at that. We have a worksheet for you guys to work through. And because it's going to be a bit tricky and you guys might need to have your hand held a little bit, I've got a similar worksheet, which is basically the same questions, just with different numbers and different letters. So what you might be able to do as you work through your worksheet and you get up to each question, you could probably watch my version of the question, see what I do, and then just apply that to your own, right? So you're pausing it and doing one question at a time. And I think if you do it that way, you might get through to the end of the sheet and have most of the questions right. All right, so let's have a go at this algebra business. So in our first question, we've been given just a rectangle and we've been asked to find the perimeter and the area of the shapes. And as I said before, the answer won't be like, a certain number of meters or kilometers or centimeters. We don't actually know what it's measured in. We've got these algebraic terms to represent how tall the rectangle is and how long the rectangle is. So it's got a height of A, which we don't know what A is, right? A doesn't mean anything. That's why algebra is really good, because I don't know how tall my rectangle is, I just call it A. What I do know is that it's a bit longer than it is tall, so we use A plus 5 to represent the length of the rectangle. So when it comes time to do perimeter and area of rectangles, hopefully you guys know your formulas. Perimeter, you just got to add up all the four sides of your shape, and area, you're just going to times this by that. Okay, so what we've learned over the last few weeks is how to actually handle operations in algebra, how to add algebra, how to times algebra. So now we're applying that to these situations, right? So for perimeter, right, I'll put some working out here, I'll put the answer up there. We've got to add up all the sides, right? So we have one side that's called A, we have another side that's A plus 5, and we need to add them together, right? But we're not going to stop there because our rectangle has four sides, not just two, right? So this side here needs to be added as well. And what you should notice is this side is the same height as that side. So we're going to add another A. And then the bottom is obviously going to be the same length as the top is. So we're going to be adding another A plus 5. All right, so all we've got to do now is do our like terms business and actually add all these things together. Right, there won't be any powers in this answer, right, because we're just adding and using like terms. So we're adding all our A's. There's an A, there's another one, another one, another one. So in our answer, we should have 4 A's. And then we've just got to add our 5's together as well, right? These are our like terms, these go together, so there should be a 10 in my answer, right? This isn't 14A. Remember, we can't put these together. I can't put A's and not A's together. So 4A plus 10 is my total perimeter, right? It doesn't have an actual answer. It's an algebraic representation of the perimeter. So with area, the formula for area, you'll hopefully remember this from previous years, is you multiply the width by the length. So we can represent that in this way. What we can do is we can say that we're going A multiplied by A plus 5, right? When we're multiplying things together in our algebra, we can put them next to each other. The a plus 5 I put in brackets because it's a whole thing that needs to be multiplied by the a. So what you'll see is this is an expanding brackets question, right? The a that was from here needs to multiply inside there. So now we are going to have powers in our answer because I'm going a times a. Remember, adding didn't give me a power, but multiplying does. So a squared will be the first part of my answer, and then a times 5 we like to write as 5a. All right, so I don't actually know how big this rectangle is, but I can model or predict its area or summarize it um, by putting together the sides for perimeter and multiplying them for area, and I've got my answer. Your 1b, it's going to be the same thing, but there's just a little bit more spice in the two things we're putting together. So perimeter, again, I'm going to add up the four sides. So I've got an x take away 3. I'm going to have to add the top, x plus 4. I'm going to have to add this side over here, which means I'm going to be adding another x take away 3. And I've got to add the bottom as well, which is going to be another x plus 4. So when I add all of these things together, we should be looking for like terms again. So we've got x's here, 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 and here. So again, my answer is going to have 4x in it. And then we're just going to check what our numbers all add up to. So we've got a couple of plus 4s, and we've got a couple of minus 3s, and they all have to go together. So it's easier if we add the positive numbers first and then take the negative. So 4 plus 4 is 8. Take away 3, gets me down to 2. So it's still positive 2. So we'll put the plus in between our two terms, and we put a 2 there. So our perimeter is 4x plus 2. With our area, we're doing the same thing again. We're multiplying this side by that side. So to show that multiplication, we're going to put the first one in brackets because it's got two parts to it. And we've got to put the second part in brackets as well. X take 3 times x plus 4. So again, we're expanding brackets, but we're practicing what we've learned, which is this first bracket, everything in it needs to multiply the second one. So we're going to be multiplying this x in to that bracket first. This times that, this times that. So that will give us x squared for a start, and 4x. And then the x is finished multiplying, but the minus 3 has to do its job as well. Right, so the minus 3 is going to go there, it's going to go there. So that will give us minus 3x from going the minus 3 times the x, and then I get negative 12 from putting those last two together with multiplication. So when it comes time to write my final answer, there are no like terms for x squared. The 4x take 3x can be simplified and put together, right? These are my like terms in this question. So 4x take 3x is just x. So I'm going to go plus an x, right? We didn't put these together because x squareds and x's are different. And then there's a minus 12, right? So we found the area of a slightly harder rectangle. All right, so for the next one, we're looking for an area of a shaded region. So again, we're working with rectangles. This is like a rectangle with a smaller rectangle cut out of it. So if I want to find the area of it, what I'll have to do is find the area of the entire thing. So I'm going to be finding the area of this red one that I'm drawing here. And then I'll find the area of the blue rectangle. And I can just take that away from the red one because that's area that's been removed from it. So the area rule again for rectangles is multiply the length by the width. So we're going to multiply these together. It's more like 1a than it was 1b that we just did. So the 3x needs to multiply 5x take 3. And when we do that, 3x times 5x gives me 15x squareds, right? Make sure the x and the x go together to make x squared, and the 3x and the minus 3, it's going to be a negative, right? I got a positive and a negative. 3 times 3 is 9, and there's an x there as well. So this is an expression for the overall area for the red part before I actually chop it out, right? So it's like I've got a big full backyard and I'm like figuring out the area of my swimming pool or something that's going in it. So the actual area of that one there then, we're doing the same thing, right? We're going the length of it times its width. So the x will multiply into 2x, and we get 2x squared, and the x will multiply 1, and that's just x. All right, so what we then need to do is we need to take away this bottom one from the top one. Right, we're going to be subtracting everything here from everything there. So let's just look at what we start with, and then let's take away what's in the second one. So my whole expression had 15x squareds. I need to take away 2x squareds. That will leave me with 13x squared in my answer. All right, putting those like terms together. And this one started with negative 9x's. I've got to take away another x. So if I'm down at minus 9, and I take away another one, that'll put me down to minus 10. So the overall area of just this shaded part here, right, in my backyard, but without my swimming pool now, it's 13x squared, take away 10x's. Right, so the next one is also going to be a problem looking for a shaded area. So we're trying to figure out how much area we've got here. We're starting with a big block, and we're kind of getting rid of these edges here. So the trick to this one is we've got to figure out an expression for how long it is, this part here, and an expression for how tall it is. So what they've told us is that the entire width or the entire length of this square block here, this square board, is called x. But then we're taking away some stuff from it, right? So we're very simply starting with x and taking away 5. So we can just like literally write that out, yeah? So if I want to know how long this board is, it's basically x take away 5, right? I start with a full length of x, I take away 5 from it. And then for the height of it, same idea. I started with x, and I subtract 7. All right, and I've put them next to each other because we're going to multiply them because we want the area of this part here. Right, and the area is the length times the width. So we get to practice our expansion skills again. Right, we get to chuck the x in, and then we get to chuck the minus 5 in as well. So when I multiply by the x times x gives me x squared, and x times minus 7 gives me minus 7x. All right, we're done using the x. We're on to the minus 5. Minus 5 times x is minus 5x, and minus 5 and minus 7, two negatives make a positive, so I get 35. Then to finalize this answer, to finish it off, x squared has no like terms. There were no other x squareds there. Minus 7x and minus 5x makes minus 12. Right, I was at negative 7. I went down 5 more. Right, I spent $7. I spent 5 more dollars. That's minus $12. If it helps to think about just being in debt or something. And the plus 35 has no friends, no like terms, so it's part of my answer. And that's it. That's done. All right, so we're moving on from blocks of land or area of rectangles now to cows. It's a very important skill to know how many cows you've got because you never count your cows before they've hatched. So we've got Evan, Clary, and Boris. They're all cow farmers with lots of cows. And Evan has N cows. Right, he doesn't actually know how many cows he's got. He knows he's got N, but for some reason all he knows is that Clary has 20 more cows than him. So if we knew that Evan had 20 cows, well, Clary would have 40. But the amount of cows Evan has is unknown, or it might change. But we know that Clary always has 20 more than Evan, right? If Evan gets a new cow, Clary gets a new one as well to stay 20 in front. Or, if Evan makes hamburgers out of a cow, then Clary has to do the same thing just to stay 20 in front. So because this N might change, and we don't know what it is, we just say that Clary is N plus 20, right? She's got 20 more than N. So we can put that there. That's Clary's amount. And Boris has 30 more, right? So same idea, N plus 30. And then all we need to do is write an expression in its simplest form. We want to know how many total cows we've got. So we're just doing like terms again. Look at all the N's we've got, 1, 2, 3. So there are 3 N's between them. And the 20 and the 30 make 50, right? So however many cows Evan's got, we triple it and add 50. That's all their cows put together, right? But it's just basic like terms, adding them together. No powers, remember, we're not multiplying. 3n plus 50. All right, in question 5, we've got Suki going to work. She earned M dollars on Monday. All right, so that's just her amount of dollars she got on Monday. We don't know what it is. We don't need to guess at it. It's just something we don't know. What they're going to tell us, though, is what happened Tuesday, Wednesday, Thursday, Friday. So on Tuesday, she earned twice this amount, 2 times as much. The easiest way to write that is to say that she got 2 M's. Right, whatever she got it twice on Tuesday. All right, on Wednesday, she got $20 more than Monday. So in this case, we're not timesing by 20 or anything, right? It's just M dollars, what she got on Monday, plus 20 more. On Thursday, she earned $10 less than she earned on Monday. So it's M, take away 10. And then Friday is another one with some more dollars. So we start with M, and then we add 30. Right, so we've written expressions for each one. We can't just go straight to the answer here. We really do need to write down what all the different expressions are. Right, Monday, Tuesday, Wednesday, Thursday, Friday. But we want an expression in the simplest form for the total amount of money across the week. So we're really going to have some M's and some numbers, right? We've got two different parts to our answer because there's two types of like terms. So for the M's, right, we've got one M here, two M's there, and another one, one, one. So that's 1, 2, 3, 4, 5, 6 M's. So she made 6 monies. I guess M is for money. And then if I add 20 and 30 and take away 10, well, that would give me 40, right? So 6M plus 40 is an expression for Suki's monies across the week. Okay, for the last one, we're playing with years. We're just going to figure out how old everyone in Bobby's family is when we add them all together. So Bobby, we start with his Y for years, right? He's going to be what we base everything else on. Everyone will be older than him, I think, or younger than him, with plussing or timesing involved. So his brother is 4 years older, so we can give him a bit of Y plus 4, right? Whatever Bobby was plus 4 more. Bobby's sister is 6 years younger. So we start with Bobby, we take away 6. Bobby's father is 4 times Bobby's age, and he's 5 years younger than Bobby's mother. So we'll get to the mum in a minute, but Bobby's father is 4 times Bobby's age. Put a comma there to show we're done reading about the dad, really. So that's just 4y, right? 4 times as much. Now it does say here that Bobby's father is 4 times Bobby's age, but he's 5 years younger than Bobby's mother. So for the mum, we've got to basically make mum 5 years older than dad. So we can start with this. All right, they try to be sneaky here and make this one tricky. That's the way they wrote that. We start with the dad and we need to make the mum 5 years older. So if I could plus 5 to the dad, I've got her. Right, so we've got Bobby, brother, sister, daddy, and mummy. And now an expression for the sum of all their ages. We're going to add all these up, put our like terms together again. We're going to have some y's and some numbers. So with the y's, we've got what? 1 plus 1 plus 1 plus 4 plus 4. So we need to have 7 y's. And then with the numbers, we've got a 4 plus a 5, take away a 6. And that leaves us with 3. So if we go 7y plus 3, we now have an expression for the Bobby family all added up together. All right, so hopefully these worked examples will help you on your own ones. You're basically doing the same thing just with a few different numbers, and hopefully it'll revise and remind you of all the processes you've learned of adding your algebra, multiplying algebra, and expanding your brackets, because it's all useful stuff in real life.